I'd like you to notice some patterns in the unit circle written in radians instead of degrees. First of all, notice that all the 30-degree angles, the ones that have 30-degree reference angles, are some form of pi over 6. So we have pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. The 45-degree angles all have a denominator of 4. And the 60-degree reference angles, 60, 120, 240, 300, all have a denominator of 3. Another thing I want you to notice is the pattern. Okay, so here we have 1 pi over 6, 1 pi over 4, 1 pi over 3, 1 pi over 2. Then we have, here notice we have 2 over 3, 3 over 4, 5 over 6. So notice that this is all a fraction of pi that is less than 1 because we haven't gotten to pi yet. Okay, so here's pi. Then when we get into quadrant 3, we have a fraction of pi that's slightly bigger than 1 pi, 7 over 6, 5 over 4, 4 over 3. Okay, so those are some things to kind of help you remember the pattern a little bit. All of these in quadrant 4, 5 over 3, 7 over 4, and 11 over 6 are all 1 less than 2 whole pi. So 5 over 3 is 1 less than 6 over 3, which would be 2 pi. 7 over 4 is 1 less than 8 over 4, which would be 2. 11 over 6 is 1 less than 12 over 6, which would be 2 pi. Okay, so those are important kind of patterns to look at as you look at fractions of pi around the unit circle. The other thing I want you to look at is the decimal equivalent. Okay, for example, pi over 3 is very close to 1 because pi is 3.14. So this is very close to 1 radian, just slightly bigger. So 1 radian is really close to 60 degrees. It's about 57.3 degrees. Then we notice that 2 pi over 3 is about 2.1. So 2 is just a little less than 120, which makes sense. 3.14 is pi, so 3 radians would be right here. So when you are looking at where to put 1, 2, and 3 radians, it should make sense among the fractions of pi. 5 pi over 4 is 3.9, 4 pi over 3 is 4.2, so 4 radians is in between, slightly bigger than the 45-degree angle, very close to the 45-degree angle, slightly bigger, so almost right in the middle of quadrant 3. 5 radians is slightly less than 300 degrees, which is 5.2 radians. And then 6 radians is in between the 11 pi over 6, which is about 5.8, and the 2 pi, which is 6.28. So realize that we can write our special angles in fraction of pi, but most of the time in real life when radians are used, they're used in decimal form. So I want you to know kind of the equivalents. Also, it's kind of good to know where pi over 2 is, which is half of pi, 3.14, 1.57. So when we go from quadrant 1 to quadrant 2, we're about at 1.5, 1.6 radians as we go from one to the other. Also, 3 pi over 2 is 4.7. So when you get a little bigger than 4.7, you're into quadrant 4. Having a good sense of where the radians are located is going to help you later on when we talk about sinusoidal functions. So those are the things I wanted you to notice for radians on the unit circle.